Our objective in this lesson is to solve problems involving sets with the use of Venn diagram. Let's have a quick review. Match the Venn diagram to its corresponding set relationship. This means the common elements of A and B. So this is A intersection B. This means the elements found in set A or in set B or the common elements of set A and B. This is A union B. This means the elements found in the universal set but not found in A. So this is A prime. While this one means the set of all elements found in A are also found in B. So set A is a subset of set B. Venn diagram formula for two circles. The cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. We are subtracting the cardinality of A intersection B because the elements here are already considered in the cardinality of A and the cardinality of B. Let's have an example. 100 students were randomly selected and it was found out that 40 are playing ML, 50 are playing COD, 20 are playing both ML and COD. Before we answer the following questions, let us create the Venn diagram for this. So let us create our rectangle for our universal set. And then we have here ML and COD, so we need two circles. Let us create one. Let us label this as set M for ML. And another one, let us label it C for COD. The technique in solving word problem involving two circles is to start with a number that contains both sets. So we have here 20 are playing both ML and COD. So that is the intersection of set M and set C. So we're going to put 20 here. And then we have here 40 are playing ML, but we already have 20 here. So we're just going to write 20 here. 20 plus 20 is equal to 40. 40 are playing ML. Next, 50 are playing COD. So this sets C 50, but you already have 20 here, so we're just going to write 30 here. Now, 20 plus 20 plus 30 is equal to 70. But it says here 100 students were randomly selected. So there are missing 30 students. So where are we going to place 30? We are going to place 30 here in the universal set. This is the number of students who do not play ML or COD. So let's have letter A. How many students neither play ML nor COD? We just answered that and we know that the answer is 30. But let me show you how it is computed. We are looking for the cardinality of M union C prime. Why prime? Because this is the set of elements found in the universal set but not found in M or C. So this will be equal to the cardinality of the universal set minus the cardinality of M union C. I have already shown the formula for this. So let us copy the cardinality of the universal set. And the formula for this one is the cardinality of M plus the cardinality of C minus the cardinality of M intersection C. Let us substitute the given. The cardinality of the universal set is 100. The cardinality of M is 40. The cardinality of C is 50. And the cardinality of M intersection C is 20. 40 plus 50 is 90, minus 20 is 70. 100 minus 70 is equal to 30. So we are correct. The cardinality of students who neither play ML nor COD is 30. Next one, letter B. How many students play at least one of both games? When we say at least one, it could be at least ML or at least COD, or both of ML and COD. So that would be the cardinality of M union C. We already know the formula, cardinality of M plus cardinality of C minus the cardinality of M intersection C. So cardinality of M again is 40, cardinality of C again is 50, and the cardinality of the intersection of M and C is 20. So 40 plus 50 is 90, minus 20 is equal to 70. In Venn diagram, we can easily see that 20 plus 20, 40 plus 30 is 70. Last one. How many students play only one of ML or COD? Meaning students that play only ML or only COD. Cannot be both. So we are looking for this shaded area here. So using the Venn diagram, we can easily answer the question, and that would be 50 students. Now let me show you that in a formula. This is another set relationship, and we call this symmetric difference, and it is denoted by this one. So the cardinality of the symmetric difference of set M and C is equal to the cardinality of M minus C. So meaning the difference of M and C, we're going to subtract the elements of C from the elements of M. So that means subtracting their common elements. Union with the cardinality of C minus M. This time we're going to subtract the elements of M from the elements of C. That again will lead us to subtracting the common elements of M and C. So it will leave us now with this shaded portion. So let's do it. So that would be 40, that is the cardinality of M, subtracting the common elements with C minus 20. Union means plus the cardinality of C minus M. So we're going to subtract the elements of M from the elements of C. So that would be 50 minus the common elements from set M. So 50 minus 20. 40 minus 20 is 20, plus 50 minus 20 is 30, and 20 plus 30 is equal to 50. And we are correct. 20 plus 30 is equal to 50. This time, let's have Venn diagram formula for three circles. We have the cardinality of A union B union C is equal to the cardinality of A, so this portion, plus the cardinality of B, this portion, plus the cardinality of C, this portion. Like in two circles, we're going to subtract their intersections. So minus the cardinality of A intersection B, so this portion here, minus the cardinality of B intersection C, so this portion here, and minus the cardinality of A intersection C, so this portion. Now, when we subtracted these three intersections here, this middle part were also omitted. But we need that. So that is why we're going to add the cardinality of A intersection B intersection C. Let's have an example. In a survey of 200 courting men, it was found out that here are the details. So let us create the Venn diagram for this. So let us construct our rectangle for the universal set. Now we have here three sets: roses, chocolates, and stuffed toys. So we're going to create three circles: chocolates, stuffed toys, and roses. The technique in solving three circles Venn diagram word problem is the same with two circles Venn diagram. You always start with the number that has the combinations of all the sets given. So we have here 5 give roses, chocolates, and stuffed toys. So this 5 here, we're going to put that at the middlemost part. So we'll write here 5. And then you go up. So we have here 10 give chocolates and stuffed toys. So chocolate and stuffed toys, so that would be this portion. but we already have 5 here. So we're just going to write 5. Next, go up. 15 give roses and stuffed toys. So that would be roses and stuffed toys. So this portion here. But we already have 5 here. So this will just be 10. Then next, go up again. 40 give roses and chocolates. So roses and chocolates, this portion is the intersection. We already have 5. So this will just be 35. Next, go up again. 50 give is stuffed toys. So stuffed toys here. So the totality of this set must be 50. We already have 5, 10 plus 10, 20. So 50 minus 20, this will just be 30. And then we have 80 give chocolates. So the totality of those men giving chocolates is 80. We already have 35 plus 5 is 40 plus 5 is 45. 80 minus 45 is 35. And last one, 90 give roses. So this portion, 90 is the total number. We already have 35 plus 5, 40 plus 10, 50. So 90 minus 50 is equal to 40. Now, how many courting men? There are 200. Let us add all these numbers here. 35 plus 35 is 70, plus 5 is 75, plus 5 is 80, plus 30 is 110, plus 10 is 120, plus 40 is 160. So that means 200 minus 160, there are 40 men who are not giving either chocolate, stuffed toys, or roses. Now let us answer the question. How many men are not giving any one of this? We just answered that, and that is equal to 40. Next, how many men give roses only? So just roses, no intersection with the other set, and that is 40. How about chocolates only? That would be 35. And stuffed toys only? That would be 30. Try this. Out of 50 street children, 35 say they have their mothers only, 18 have fathers only, and 10 says they have both parents. Let us construct the Venn diagram for this. We have two sets, mother and father. Let us label this one as M for mother and this one is F for father. It says here 10 have both parents, so the intersection of mother and father is 10. 35 have mothers only. So for set M, 35, you already have 10. So this will just be 25. 18 have fathers only. So for set F, 18, you already have 10 here. So this will just be 8. Now, how many children don't have either of their parents? So they don't have their mother or their father or both. So all we have to do is to add all of this. 25 plus 10 is 35 plus 8 is 43. But there are 50 street children. 50 minus 43 is equal to 7. So there are 7 street children that do not have either of their parents. Letter B, how many children have either one of their parents? So they could have a mother or a father or both mother and father. So we simply have to add these three numbers here. Again, 25 plus 10 is 35 plus 8 is 43. And last one, what is the probability that a randomly selected child has a mother only? So mother only is 25 and there are total of 50 street children. So 25 divided by 50. In lowest term, this is 1/2. In decimal form, this is zero point 0.5. We are asked to give the probability and it is commonly expressed in percentage. So zero point 0.5 in percentage is 50%. So this means the probability that a randomly selected child has a mother only is 50%. Extra challenge: in a survey of 84 teachers, it was found out that they can teach at least one of the following subjects: English, history, and math. So here are the data and here are the questions. Let us create first the Venn diagram. So we have three circles here because we have three sets: English, history, and math. Oh, this is a bit tricky because we do not have a number that says the teacher can teach the three subjects. So this portion, the middlemost part, is unknown. So we're going to label this as X. Now, let's go up. 7 can teach English and math. English and math. So this portion here is 7. But this portion is x. So this will be 7 minus x. And then we have 11 can teach history and math. History and math. So this is the intersection. The total number of this must be 11. If this is x, then this portion here is 11 minus x. And then we have 16 can teach English and history. English and history, so the intersection is equal to 16. But this middlemost part again is x, so this will just be 16 minus x. So where are we going to use this number 25? It says here 25 can teach exactly two subjects. So it is either English and history, English and math, or history and math. So meaning these three here is equal to 25. So let us create the equation. We have 16 minus x plus 11 minus x plus 7 minus x is equal to 25 because 25 can teach exactly two subjects. Again, either English and history, English and math, or history and math. Let us combine like terms. Let's have first the constant. We have 16 plus 11 plus 7. And then we have minus x, another minus x, another minus x equals 25. 16 plus 11 is 27 plus 7 is 34. Minus x is negative 3x. So 34 minus 3x. Let us move 3x to the other side and let us combine 25 with 34. Moving this to the other side will become negative. So 34 minus 25 is equal to 3x. 34 minus 25 is equal to 9. So 9 is equal to 3x. To solve for x, let us divide both sides by 3. So 3 here will cancel out. And 9 divided by 3 is equal to 3. Therefore, x is equal to 3. So this x here is equal to 3. If x is equal to 3, then 7 minus 3 is equal to 4. 11 minus 3 is equal to 8. 16 minus 3 is equal to 13. Now, let's go up again. 25 can teach math. So this is math. The total number is 25, but we already have 4 plus 3, 7 plus 8 is 15. So 25 minus 15 is equal to 10. And then 50 can teach history. So the total number in history must be 50. We already have 13 plus 3 is 16. 16 plus 8 is 24. 50 minus 24 is equal to 26. And then 40 can teach English. So the totality in English must be 40. We already have 13 plus 3 is 16. 16 plus 4 is 20. So 40 minus 20 is equal to 20. Let us check if all 84 teachers are accounted for. Let us add all these numbers here. 20 plus 13 is 33. 33 plus 26 is 59. 59 plus 4 is 63. 63 plus 3 is 66. 66 plus 8 is 74. And 74 plus 10 is 84. So we have no numbers here outside these three circles because it says here they can teach at least one of the subjects. Now that we are done with the Venn diagram, let us answer the questions. How many teachers can teach English only? So English only, that would be 20. How many teachers can teach math only? Math only. We're not going to consider the intersection, so that would be 10. How many teachers can teach all three subjects? So that would be the intersection of English, history, and math, and that is 3. How many teachers can teach English and history but not math? English and history, so this portion, but not math. So we are going to subtract the portion that intersects with math, and that will only be 13. Now it is time to check your understanding. Pause this video for more time. Let us answer. In a survey of 250 math major students, it was found out that here is the data. Let us construct first the Venn diagram. Let us label this. We have three sets here, so we need three circles: algebra, geometry, and trigonometry. Let us start with the number that has the intersection of the three sets, and that is 15. 15 likes the three subjects. So we're going to place 15 here at the middlemost part. Going up, 20 likes geometry and trigonometry. Geometry and trigonometry, 20. We already have 15 here, so this will just be 5. Going up, 40 likes algebra and trigonometry. Algebra and trigonometry, 40. We already have 15 here, so this will just be 25. 50 likes algebra and geometry. Algebra and geometry, 50. We already have 15 here, so this will just be 35. 70 likes trigonometry. So total for trigonometry is 70. We already have here 25 plus 5 is 30. 30 plus 15 is 45. So 70 minus 45 is 25. 85 likes geometry. A total of 85 for geometry. We already have 35 plus 15 is 50 plus 5 is 55. So this will just be 30. And 95 likes algebra. Total of 95 for algebra. We already have 35 plus 15 is 50. 50 plus 25 is 75. 95 minus 75, this will just be 20. Question: determine how many students do not like any of these subjects but other math-related subjects. Probably statistics or solid mensuration. So let us see. All we have to do is to add all these numbers here. 20 plus 35 is 55. 55 plus 30 is 85. 85 plus 5 is 90. 90 plus 15 is 105. 105 plus 25 is 130. 130 plus 25 is 155. But there are 250 math major students, so 250 minus 155 is equal to 95. So meaning there are 95 students who do not like algebra, geometry, or trigonometry. Maybe other math-related subjects. Gets? Our next lesson is absolute value and integers.